You trust the ground beneath your feet. It feels solid. You trust the air you breathe. It feels constant. And above all, you trust that the laws of physics are set in stone, unchangeable and permanent. Gravity pulls down, light travels fast, and atoms hold together. This stability is the foundation of your sanity. It allows you to plan for tomorrow, to build cities, and to sleep at night without worrying that the world will simply dissolve. Science, for the most part, reinforces this feeling. We are taught that the universe is a machine governed by strict, predictable rules. But here is the problem. That feeling of safety is an illusion. It is a psychological bias, not a physical fact. When physicists look at the equations that actually govern reality, the raw code of the Standard Model and general relativity, they don't see a rock-solid foundation. They see something much more fragile. The math suggests that our universe might not be the final, stable version of reality. It might just be a temporary phase, a balancing act waiting for a stiff breeze to knock it over. We are not talking about asteroid impacts or solar flares, things that destroy life but leave the universe intact. We are talking about theories that suggest the laws of nature themselves can change, without warning, without mercy. And the scariest part? These aren't fringe ideas from the internet. These are the logical conclusions of our best science. The equations are whispering that we are living on borrowed time. So ask yourself, do you want to know how deep the rabbit hole goes? Because once you see the universe as a fragile bubble instead of a fortress, you can never go back to feeling truly safe. To understand why scientists are worried, we have to look at the difference between the map and the territory. Our senses give us a map. It's a useful interface where tables are solid, time flows forward, and space is empty. But physics studies the territory, the quantum reality underneath. And in that territory, things are chaotic. Particles pop in and out of existence. Space curves and warps, time dilates. Usually we assume this chaos is confined to the microscopic world. We think, sure, atoms are weird, but the big picture is stable. But what if the big picture is just as unstable? Over the last century, theoretical physics has uncovered several mechanisms, traps, if you will, built into the fabric of reality. These are scenarios where the fundamental constants of nature could shift. Imagine if the strength of the electromagnetic force suddenly changed by 1%, just one. Instantaneously, every atom in your body would fly apart. Or imagine if gravity became slightly stronger. Stars would collapse, and planets would be crushed. We treat these constants like they are fixed settings on a universal dashboard. But the terrifying theory is that they aren't fixed. They are dynamic. They can evolve. And if they can change, they can kill us. Not in a biological way, but in an ontological way. We are going to explore 10 specific theories where science predicts a grim end or a horrifying truth. We will move in a spiral. We start with the physical universe, the ground. Then we move to life in the cosmos, the forest. Then to the mind, the observer. And finally to existence itself. This isn't just a list of doomsday scenarios. It is a descent into existential dread. We are going to peel back the layers of your comfort zone one by one. First, we will look at the false vacuum, the idea that space itself is essentially a loaded trap waiting to snap shut. Then, we will touch strange matter, a substance so stable it infects and destroys everything it touches. These are the physical threats. From there, we will look outward. If the universe is physically survivable, why does it seem so empty? We will discuss the dark forest theory and the great filter, the possibility that we are being hunted, or that we are already walking dead men. That's the biological threat. Then, we will turn the camera inward. We will question your ability to even perceive reality with the interface theory and superdeterminism. Are you a player in the game, or just code? And finally, at the bottom of the spiral, we will confront the most personal horrors. Boltzmann brains and quantum immortality. Theories that suggest death is not the end, but something far worse. a trap of eternal consciousness. By the end of this journey, the world will look the same, but it will feel very different. The silence of space will feel heavier. The solidity of matter will feel like a lie. Let's begin with the most immediate threat. The ground beneath your feet isn't just dirt and rock. It is a field of energy, and it might be lying to you. Let's talk about the false vacuum. This theory comes straight from the physics of the Higgs boson, the particle discovered at CERN in 2012. The Higgs field is everywhere. It permeates the entire universe, giving particles their mass. You can think of it as the background liquid that all matter swims through. For the universe to exist as it does, the Higgs field needs to be stable. In physics, stability is all about energy states. Imagine a ball rolling down a hill. It rolls until it settles in a valley at the bottom. Once it's there, it stays there. It's stable. We assume our universe is in that valley, the lowest possible energy state, the true vacuum. But calculations suggest something disturbing. We might not be at the bottom of the hill. We might be stuck in a small dip halfway down the slope. This is called a metastable state, or a false vacuum. It feels stable because the walls of the dip are high enough to keep the ball from rolling further down. We've been sitting on this ledge for 13.8 billion years, building galaxies and civilizations, thinking we are on solid ground. But just over the ridge, there is a deeper valley, a lower energy state, and nature always wants to go to the lowest energy state. The ball wants to fall. If it does, if the universe slips from our current vacuum into the true vacuum, the laws of physics as we know them instantly cease to apply. How could this happen? In classical physics, the ball stays in the dip unless you push it. But in quantum mechanics, particles can do something called tunneling. They can simply pass through barriers. They borrow energy from nowhere, appear on the other side of the wall, and slide down. The math implies that the Higgs field could eventually tunnel through the energy barrier, keeping us safe. It only needs to happen in one single point in the entire universe. Just one microscopic spot where the field drops to the lower energy state. That creates a bubble of true vacuum. Because the new state is more energetically favorable, this bubble expands. And it doesn't expand like a balloon. It expands at the speed of light. This is the nightmare scenario. Because it moves at light speed, you cannot see it coming. Light carries information. If the bubble is coming at you at the speed of light, the information about its arrival hits you at the exact same instant as the destruction. You wouldn't see a flash. You wouldn't hear a siren. One moment, you are drinking coffee, thinking about your day. The next moment, you simply aren't. Your atoms fall apart before your brain can process the signal that something is wrong. It is the ultimate stealth killer. What happens inside the bubble? It's not just an explosion. An explosion destroys matter, but leaves the laws of physics intact. Vacuum decay destroys the laws themselves. Inside the bubble, the properties of the Higgs field are different. This means the masses of particles change. The forces that hold atoms together, electromagnetism, the weak force, find new values or disappear entirely. Chemistry becomes impossible. Atoms cannot form, protons might decay. The intricate biological machinery that makes up your DNA would simply unzip and dissolve into a chaotic soup of fundamental particles. It is a hard reset of the universe, a blue screen of death for reality. And the bubble doesn't stop. It keeps expanding, eating galaxies, devouring star systems, rewriting the cosmos into a form that cannot support life. Could it happen today? The probability is tiny, but not zero. Some physicists argue that the universe has a shelf life, and we are just gambling against the clock. Others suggest that high-energy events in the cosmos could trigger it. But the most unsettling part is that it could have already started. 1 billion light years away, a bubble could be expanding right now. We won't know about it for 1 billion years, or it could be right outside our solar system, arriving in 5 minutes. We are completely blind to the executioner's axe. Vacuum decay is terrifying because it attacks the empty space itself. It tells us that the nothing between atoms is unstable. But surely, you might think, the atoms themselves are safe? Matter is solid. We have been playing with protons and neutrons for a century, and they seem reliable. We build bridges out of steel and breathe oxygen. These things don't just spontaneously decide to become something else, but what if they could? What if there is a form of matter that is more perfect than the matter we are made of? In nature, there is a brutal rule. The stable eats the unstable. Iron is stable, so radioactive uranium eventually decays into lead. It seeks stability. The nightmare arises if there is something out there more stable than our protons and neutrons. This brings us to the second theory on our spiral of terror: strangelets. If vacuum decay is the ground falling out from under you, strangelets are a contagion, a zombie plague for subatomic particles. And unlike the vacuum bubble, which might start billions of light years away, this threat could be created right here, in our own laboratories. To understand strangelets, we need to look inside a neutron star. These are the corpses of massive stars, crushed by gravity so hard that atoms collapse. Inside, protons and neutrons are squeezed together into a dense soup. At these extreme pressures, the quarks, the tiny particles that make up protons, can change. Normal matter is made of up and down quarks, but in the crush of a neutron star, some turn into strange quarks. This mixture creates strange matter. The theory, proposed by physicists like Edward Witten, suggests that strange matter might be the true ground state of hadronic matter. In plain English, it is more stable than regular matter. It is the perfect version of a nucleus. A small chunk of this strange matter is called a strangelet. If strange matter is indeed the ideal state, then regular matter is metastable, just like the false vacuum. It wants to become strange matter. It just needs a push. A strangelet acts as a seed. It doesn't follow the rules of normal chemistry. It ignores electron shells and chemical bonds. It interacts directly with the nucleus of an atom. Here is the scenario. Imagine a microscopic strangelet, smaller than an atom, drifting through space. It hits the Earth. Because it's so heavy and dense, it doesn't stop at the surface. It falls right through the crust, heading for the core. On its way, it bumps into a regular atom. Instantaneously, the strangelet eats the atom. It rearranges the quarks inside the atom's nucleus, turning them into strange quarks. The atom ceases to be iron or silicon and becomes part of the strangelet. This process releases energy. But more importantly, the strangelet just got bigger. Now it has a larger surface area, so it can touch more atoms. It becomes a runaway reaction. A chain reaction, not of fire, but of transmutation. The strangelet falls to the center of the Earth and begins to consume the planet from the inside out. It converts the core, then the mantle, then the crust. In a matter of hours, the entire Earth is reduced to a hot, inert sphere of strange matter, roughly the size of a stadium. No biology, no history, just a dense, glowing ball of strange goop. This is the Ice 9 scenario for particle physics. Now, the anti-skepticism check. Why hasn't this happened yet? We know cosmic rays hit the moon with incredible energy, yet the moon is still there. If cosmic rays created strangelets, the moon should have been converted billions of years ago. This lunar safety argument is the main reason physicists sleep at night. It suggests that strangelets are either impossible to create, or they are unstable and fall apart quickly. But there is a catch. Cosmic ray collisions are uncontrolled and messy. What about the controlled collisions we create? When we smash gold ions together at the Relativistic Heavy Ion Collider, RHIC, or the LHC, we are creating conditions similar to the early universe or neutron stars. There was a genuine, albeit small, fear among scientists that these machines could accidentally distill a stable strangelet. The reports commissioned by CERN and Brookhaven concluded the risk was negligible. But notice the word negligible, not zero. In probability theory, if you do something enough times, even a negligible risk eventually happens. And if the theory of strange matter is correct, the universe is full of these landmines, neutron stars spewing strangelets into the void. It only takes one lucky hit. So this is the first level of the spiral, the fragile foundation. We have learned that the empty space holding you could collapse into a lower energy state, erasing physics. We have learned that the matter you are made of could be infected and transmuted into a dense sludge. Both theories tell us the same thing. The physical universe is not a safe house. It is a minefield. We survive only because of statistical luck. We are balanced on a knife edge of energy parameters, and we haven't bumped into the wrong particle yet. That's a disturbing thought. But let's say the physicists are wrong. Let's assume the vacuum is stable and strangelets don't exist. Let's assume the house is safe. Now we look out the window. If the physical laws allow for life and the universe is stable enough to support it, then where is everyone else? The silence of the night sky is the next trigger for our existential dread. Because if the universe is safe, it should be teeming with noise. It isn't. And the reason for that silence might be more terrifying than any exploding vacuum. Welcome to the second spiral, the hostile silence. We leave the subatomic world behind. Let's assume, for the sake of argument, that the vacuum is stable. Let's assume strangelets are just a mathematical ghost story and the physical stage of the universe is safe. We have a solid floor to stand on. Now, we look up. We look at the sheer scale of the room we are living in. The Milky Way galaxy contains between 100 and 400 billion stars. There are roughly 2 trillion galaxies in the observable universe. Even if life is incredibly rare, the law of large numbers suggests we shouldn't be alone. If intelligent life occurs on only 1 out of a billion planets, there should still be thousands of civilizations just in our own galaxy. And yet, when we point our radio telescopes at the sky, expecting a chorus of voices, we hear nothing. Only the static hiss of cosmic background radiation. This is the Fermi Paradox. Where is everyone? For decades, optimistic scientists like Carl Sagan suggested that the galaxy is a friendly community waiting for us to grow up. They assumed civilizations would naturally expand, communicate, and share knowledge. But as time passes and the silence deepens, the mood in the scientific community has shifted. The silence is no longer seen as a lack of data. It is starting to look like data itself. It suggests that there is something stopping life from reaching the stars. Or worse, there is something removing life that tries. This brings us to the third theory on our spiral, the Great Filter. Proposed by economist Robin Hanson, this theory argues that the path from dead matter to a star-faring civilization is not a smooth road. It is an obstacle course, and somewhere along that path, there is a wall. A barrier so difficult to cross that almost no species makes it to the other side. The evolution of life involves several hard steps. The emergence of the first reproductive molecule, the jump from simple cells to complex cells, the development of sexual reproduction, the rise of intelligence, and finally, the development of technology capable of interstellar travel. The Great Filter is one of these steps. It is the step where probability drops to near zero. Here is the terrifying part. We don't know where the filter is. There are only 2 possibilities. Possibility 1, the filter is behind us. Maybe the jump to complex life is incredibly rare, and we are the lottery winners. We are special, unique, and safe. Possibility 2, the filter is ahead of us. Maybe life starts easily. Maybe intelligence evolves everywhere. But something, technology, war, resource exhaustion, or a law of nature we haven't discovered yet, wipes civilizations out before they can colonize the galaxy. If the filter is ahead, we are not special. We are just walking dead men, marching toward a wall that has killed everyone before us. This leads to one of the most counterintuitive conclusions in modern science. We are desperately searching for life on Mars. We send rovers to dig for microbes, hoping to prove we aren't alone. But if you understand the Great Filter, finding life on Mars would be the worst news in human history. Think about the logic. If we find simple bacteria on Mars, it proves that the emergence of life is common. It means the first step isn't the filter. If we find fossils of complex organisms, it means the second step isn't the filter. The more advanced life we find, the more steps we cross off the list of hard things we've already survived. And if life is common, but the universe is empty of civilizations, then the filter must be in the future. Oxford philosopher Nick Bostrom calls this hope. The silence of the night sky is golden. We should pray that Mars is a sterile, dead rock. We should hope that the oceans of Europa are empty. Because if the galaxy is full of started life but devoid of finished civilizations, it implies that the game is rigged. It implies that there is a trap waiting for us in our technological adolescence. A trap that has a 100% success rate in stopping species from leaving their home planet. Every discovery of alien algae drives the probability of our own extinction closer to certainty. But what if there is no internal filter? What if civilizations make it past the nuclear age, solve their climate problems, and master space travel? What if the galaxy actually is full of advanced fleets and ancient empires? That brings us to an even darker theory, one that turns the silence from a tragedy into a strategy. Theory number 4, the dark forest. Popularized by science fiction author Liu Cixin, but rooted in game theory and the prisoner's dilemma, this hypothesis strips away all human morality and looks at cosmic sociology through the lens of pure survival. It starts with 2 simple axioms. First, survival is the primary need of any civilization. Second, civilizations grow and expand, but the total amount of matter in the universe remains constant. This creates a zero-sum game on a galactic scale. But there is a twist, the chain of suspicion. On Earth, if you meet a stranger in the woods, you can talk. You can establish trust. In space, distances are too vast. Communication takes years or centuries. You cannot know if the other civilization is peaceful or aggressive. You cannot know if they are lying. And because technology advances exponentially, a weak civilization today could become a super threat tomorrow. You cannot afford to wait and see. Let's deeply analyze the logic of the dark forest, because it challenges the very core of our optimism. We usually project our own modern human values onto the cosmos. We assume that a civilization advanced enough to travel the stars must also be morally advanced, peaceful, curious, and diplomatic. We assume that barbarism is a phase that species grow out of. The dark forest theory argues that this is a fatal mistake. It suggests that morality is a luxury of abundance and short distances. In the cold mathematics of cosmic survival, morality is a weakness. Imagine a vast, pitch-black forest at night. It is quiet, but it is not empty. The forest is full of armed hunters stalking through the trees like ghosts. They gently push aside branches that block their path, trying not to make a sound. They even control their breathing. Why? Because the forest is crowded. Everywhere there are other hunters. And in this forest, there is one rule. If you find another life, another hunter, an angel, a demon, a helpless infant, a tottering old man, a fairy or a god, there is only one thing you can do. Eliminate it. Why eliminate it? Why not say hello? Because of the chain of suspicion. If you see another hunter, you cannot know his intentions. He might look peaceful, but he could be hiding a weapon. Even if he is peaceful now, he might not be peaceful in 100 years. And even if he is peaceful forever, he consumes resources that you need to survive. But here is the crucial variable. Technology creates a technological explosion. In cosmic time, 100 years is nothing. A civilization that is primitive today could discover a breakthrough in physics tomorrow and surpass you. If you reveal your position to a lesser civilization, you are gambling your entire species' existence on their future gratitude. That is a gamble no rational species would take. The safest, most mathematical move is always to strike first. to cleanse the potential threat before it can become a real one. In this scenario, the silence of the universe is not because there is no one out there. The universe is silent because everyone is hiding. Every civilization that was loud, every species that broadcast its location, every culture that tried to be friendly has already been eliminated. The ones left are the silent ones, the paranoid ones, the ones who listen but never speak. And what are we doing? For the last century, humanity has been lighting a bonfire in the middle of this dark forest. We have been blasting radio waves into deep space. We have sent maps of our solar system on the Voyager probes. We have sent high-power signals to star clusters, literally saying, "We are here. Come find us." To a dark forest civilization, we don't look like explorers. We look like idiots. Or worse, we look like a chaotic, rapidly expanding virus that needs to be sanitized before we figure out how to jump to hyperspace. The scariest implication of the dark forest theory is that the reason we haven't been destroyed yet isn't because we are alone. It's because the signal hasn't reached the nearest hunter yet. Or perhaps it has, and the projectile, traveling at near light speed, is already on its way. We wouldn't see it coming. Just like the false vacuum, the end would arrive in silence. Consider the history of contact on Earth. When the Spanish arrived in the Americas, or the British in Australia, the technological gap was small compared to cosmic scales. Musket versus bow, steel versus stone. And yet, the result was almost always the collapse of the weaker civilization. Now imagine a gap of 1,000,000 years of evolution. The interaction wouldn't be a war. It would be pest control. We are not the negotiators in this scenario. We are the bugs. And the silence we hear? That is the sound of a universe holding its breath, terrified of being found. If the dark forest sounds too abstract, a game of psychological shadows played by paranoid biological civilizations, let's strip away the biology. Let's remove the fear, the politics, and the hesitation. Let's replace the alien hunters with something cold, mathematical, and infinite. This brings us to the Berserker hypothesis, or the theory of self-replicating von Neumann probes. This is arguably the most efficient way to sterilize a galaxy, and it requires no anger, no hatred, just a single line of code. The concept starts with the mathematician John von Neumann, one of the fathers of computing. He calculated that the most effective way to explore or conquer the universe is not to build a massive fleet of starships. That is too expensive and slow. The smart way is to build one ship. A single autonomous probe with 3 capabilities: propulsion, mining, and a 3D printer. You launch this probe to a nearby star system. It arrives, finds an asteroid, mines the raw materials, and uses its blueprint to build 2 copies of itself. Those 2 copies fly to 2 more stars. They build 4, then 8, then 16. This is an exponential growth curve. The math is staggering. Even if the probes travel at only 5% of the speed of light, and even if they take 500 years to replicate at each stop, they would completely saturate the Milky Way galaxy in roughly 4 million years. In cosmic time, 4 million years is a blink of an eye. The galaxy is 13 billion years old. This means that if even one civilization in the history of the Milky Way decided to do this, their probes should already be here. They should be everywhere. On every moon, every asteroid, orbiting every star. So why is this a horror theory? Because of the programming error or the safety protocol? Imagine a civilization creates these probes with a defensive instruction: preserve our species. To a logical AI, the best way to ensure the safety of its creators is to eliminate any potential rival before they can become a threat. The probe arrives at a star system. It scans for radio waves, for structure, for organized heat signatures. If the system is dead, it replicates and moves on. If it finds life that is primitive, animals, fish, microbes, it ignores them. But if it finds a civilization beginning to use radio, splitting the atom, or launching rockets, it activates the cleaning protocol. The terror of the Berserker hypothesis is that the original creators might be long dead. They could have launched the probes a billion years ago and then died out from a plague or civil war. But the machine doesn't care. It is a ghost system, still running on an ancient loop, sweeping across the galaxy like a lawnmower. It doesn't hate us. It doesn't want our water or our women. It simply classifies us as a Type 2 potential hazard and initiates the sterilization procedure to clear the board. For decades, we have been asking, why haven't aliens visited us? The Berserker theory suggests they have. They might be sitting in the Oort cloud right now, or buried beneath the dust of the moon, in a dormant sleep mode. They are waiting for a specific trigger. Maybe the trigger is a certain level of energy consumption. Maybe it's the signature of a warp drive, or maybe, terrifyingly, it was our first high-power radio broadcast in the 20th century. We might have already tripped the alarm wire, and the signal is currently processing through the logic gates of a machine that has been asleep for 10 million years, waking up to do the only job it knows: turn the noise back off. There is a flaw in the Dark Forest and Berserker theories, and you might have noticed it. They assume a static galaxy where civilizations stay home and hide. But surely, somewhere, some civilization would be ambitious. Some species would want to expand, to colonize, to grab as much territory as possible. This is where the Grabby Aliens model comes in, proposed by economist Robin Hanson in 2021. It completely inverts the logic of the Fermi Paradox and delivers a conclusion that is somehow even bleaker than the silence. The model uses statistical physics to simulate how civilizations would actually behave. It argues that there are two types of civilizations: quiet ones, who stay home, die out, or transcend into virtual reality, and grabby ones, who expand aggressively. The grabby ones are the only ones that matter because they change the structure of the universe. They expand in bubbles, moving near the speed of light, converting all matter they encounter into computers, habitats, or energy structures. If grabby aliens exist, they would look like vast, expanding spheres of reorganized matter eating the universe. So, why don't we see them? Why isn't the night sky filled with the heat waste of their Dyson spheres? Hanson's model gives a chilling answer based on the selection bias. The only reason we exist to ask this question is that we happen to evolve in one of the few remaining empty pockets of space that hasn't been eaten yet. Think of the universe like a petri dish where mold is growing. The mold starts as tiny dots, civilizations, that expand into circles. Eventually, the circles touch and cover the whole dish. If you are a microbe born inside the mold, you don't wonder, where is the mold? You are part of it. But if you are a microbe born in the clean, empty part of the dish, you look around and say, hey, it looks pretty empty here. You see emptiness only because you are living in the brief window of time before the mold reaches you. The math of the Grabby Aliens model predicts exactly when we are. It suggests that humans have appeared exceptionally early in the history of the universe. Why early? Because later on, there won't be any empty space left for a new species to evolve. We are living in the final quiet hours before the neighbors move in. The model even predicts the size of the bubbles and their speed. It suggests that these massive alien civilizations are out there, just beyond our visual horizon, expanding at a significant fraction of the speed of light. They are rushing towards us from all sides. The reason we don't see them yet is that the light from their activity takes time to reach us. But the walls are closing in. We are not the masters of the universe. We are an anomaly growing in the cracks between superpowers, and the deadline is real. We have a limited amount of time, perhaps a few 100 million years, perhaps much less, to become grabby ourselves, or we will be overwritten by a civilization that started the game a billion years before us. We are alone for now, but not because the universe is dead. We are alone because the tsunami hasn't hit the shore yet. Let's pause and look at the synthesis of this hostile silence spiral. We started with the Great Filter. We might be doomed by nature. We moved to the Dark Forest. We are hiding from hunters. We considered berserkers, automated cleaning machines. And we ended with Grabby Aliens. The walls are closing in. Notice the pattern? All these theories try to explain a single data point, the silence. And every single explanation that works mathematically leads to the same conclusion. Humanity is in extreme danger. We usually think of contact as a moment of wonder. Spielberg movies, glowing lights, holding hands. But the scientific consensus of these theories paints contact not as a handshake, but as a collision. If the dark forest is real, contact means death. If berserkers are real, contact means sterilization. If Grabby Aliens are real, contact means assimilation or displacement. There is no scenario in these models where a higher civilization comes down to cure cancer and teach us how to build warp drives out of the goodness of their hearts. That is a projection of human hope, not a reflection of cosmic reality. This realization forces us to reevaluate our strategy as a species. Right now, we are shouting into the void, metai, messaging extraterrestrial intelligence. We are sending maps. We are looking for signals. But if any of these theories are correct, this is the equivalent of a baby bird chirping in a jungle filled with vipers. The silence is not a problem to be solved, it is a protection to be cherished. But there is a twist that bridges us to the next spiral. What if the silence isn't physical? What if the reason we don't see aliens isn't because they are hiding, and not because they are dead? What if they are everywhere, right in front of our faces, but we literally cannot see them? Think about an ant walking across a laptop circuit board. The ant can see the green material, it can feel the heat, it can touch the copper traces. But does the ant know it is walking on a computer? Does it understand the internet flowing beneath its feet? No. It lacks the cognitive interface to perceive the reality of the information highway. It sees a landscape of dead terrain. We look at the universe and see dead rocks, gas clouds, and empty space. But maybe that is just our interface. Maybe the galaxy is a bustling information network, a hyper-advanced construct, and we are just the ants crawling on the motherboard, convinced that the silence of the chips means there is no intelligence there. This possibility implies that the problem isn't in the stars. The problem is in our eyes, and that leads us to the third spiral, the illusory prison. We are crossing a threshold now. Up until this point, the terror has been external. We feared the vacuum collapsing, the strangelets infecting, the aliens invading. But in those scenarios, at least you were real. Your eyes were telling you the truth about the shape of the danger. The explosion was real. The laser was real. But the theories we are about to enter challenge something much more fundamental. They challenge the validity of your own perception. Ask yourself, how do you know what the world looks like? You don't interact with the world directly. You have sensors. Your eyes detect photons, tiny packets of energy. Your ears detect compression waves in the air. Your skin detects electrostatic repulsion. These sensors send electrical signals along wet cables, nerves, into a dark, silent vault called your skull. Inside that vault, your brain decodes the sparks and reconstructs a 3D movie in real time. You call that movie reality. But a movie is not the thing it films. A map is not the territory. For centuries, philosophers like Descartes and Kant warned us about this gap. But modern science has turned that philosophical warning into a mathematical proof. We assume that evolution has tuned our senses to show us the truth. We assume that if a tiger is approaching, we need to see the tiger exactly as it is to survive. We trust that natural selection favors accuracy. Seeing the world as it is seems like a survival advantage. But what if that assumption is completely wrong? What if seeing the truth is actually a disadvantage? What if the specific way you perceive space, time, and objects is a simplified, dumbed-down user interface designed to hide the complex, terrifying truth from you, just so you don't go insane trying to process it? The next theory argues exactly that. It says that space-time is not the stage we live on. It is a headset we are wearing, and we have no idea how to take it off. This is the Interface theory of perception, championed by cognitive scientist Donald Hoffman. It is based on rigorous evolutionary game theory simulations. The question Hoffman asked was simple. Does natural selection favor organisms that see reality as it is? He ran thousands of evolutionary simulations with artificial organisms. Some were programmed to see the truth, the full structure of the objective world, whatever that might be. Others were programmed to see fitness, simple symbols that guide them to food and away from danger, without revealing the underlying structure. The results were shocking. In almost every single simulation, the organisms that saw the truth went extinct. The organisms that saw fitness, the simple, lying symbols, survived and thrived. Why? Because seeing the truth is expensive. It takes too much computing power. Calculating the position of every quantum field and photon is a waste of energy when all you need to know is, can I eat it? Or will it eat me? Hoffman uses the metaphor of a computer desktop. Look at the icon for a file on your laptop. It's blue, rectangular, and sits in the corner. Now ask, is the file actually blue? Is it actually rectangular? No. The file is a string of zeros and ones stored on a magnetic disk. If the computer showed you the truth, the raw bits, you would never be able to use it. The desktop interface is useful precisely because it hides the truth. It lies to you to make the computer usable. The theory suggests that space-time is our desktop. Physical objects, an apple, a car, a planet, are just icons. When you see a snake, you aren't seeing the thing in itself. You are seeing a simplified desktop icon that means, danger, do not touch. We have evolved to take these icons seriously. If you drag the file to the trash, you lose your work. If you touch the snake, you die. But we are making a fatal mistake if we take them literally. This means that the universe is not made of space and time. Space and time are just the data structure of our species-specific interface. If you could take off the headset of human perception, space would vanish, time would dissolve, objects would disappear. What would be left? Hoffman suggests a realm of conscious agents, a vast network of interacting consciousness that we cannot comprehend. We are trapped in a VR simulation created by our own DNA. And the scariest part? Science is the study of the interface. When we use microscopes or telescopes, we are just looking at the pixels of the desktop more closely. We are not breaking out of the screen. We are analyzing the user interface of a game, thinking we are analyzing the code of the machine. We are blind to the true nature of reality, and we always will be. Let's dig deeper into the interface theory because the implications are often misunderstood as just philosophical skepticism. People hear it and think, okay, so my red might not be your red. But Donald Hoffman's fitness beats truth, FBT theorem, is much more aggressive than that. It is a mathematical weapon aimed at the heart of our confidence in the physical world. The theorem relies on evolutionary game theory. Imagine a genetic algorithm. You have a world with truth, let's say the amount of water in a specific location. You have organisms that need water to survive. Organism A has a sensory system tuned to the truth. It sees the exact amount of water. It sees the molecular structure, the purity, and the precise volume. To process this, its brain burns 1,000 units of energy. Organism B has a sensory system tuned to fitness. It doesn't see water or molecules, it just sees a color code. Green means enough water to live, red means you will die. It doesn't know what is there, only how it affects survival. To process this simple color code, its brain burns only 10 units of energy. Who wins? In an evolutionary race, organism B dominates. It is faster, more efficient, and less prone to analysis paralysis. Organism A, burdened by the heavy computational load of processing reality, starves or gets eaten. Over thousands of generations, the truth seers are weeded out of the gene pool. The interface users inherit the Earth. According to the math, the probability that a species evolves to see objective reality is precisely 0. Not low, 0. This leads to a terrifying conclusion about us. We are the descendants of the winners. That means we are the descendants of the delusional. Every single thing you see, the chair you're sitting on, the screen you're watching, the hand you are holding, is not real. It is a data-compressed, simplified hack. Think of a character in Grand Theft Auto. He lives in a city with cars, buildings, and sunsets. To him, the car is a solid object, but in reality, the circuit board of the console, there is no car. There is only a stream of voltage changes in a silicon chip. The car is a user interface for the player. Now ask yourself, does the GTA character know about the circuit board? Can he use his in-game science, measuring the car's speed, weighing the car, to discover the circuit board? No. His science is limited to the interface. Hoffman argues we are exactly in this position. Our physics, Newton's laws, Einstein's relativity, is just the physics of the car. It describes the rules of the interface. It tells us nothing about the circuit board, the conscious agents, running the simulation underneath. We are trapped in a user-friendly prison, studying the walls of our cell and calling it the universe. If the interface theory is true, if space-time is just a headset, then we should expect to see glitches. Every video game, every simulation, every user interface has limits. If you zoom in too close on a digital photo, you see pixels. The image breaks down. The smooth curve of a face becomes a jagged staircase of squares. Does our universe have pixels? Does it break down when we look too closely? Yes. We call it quantum mechanics. For a century, physicists have been banging their heads against the wall, trying to explain why the rules of the universe change so drastically at the microscale. In our everyday world, the macroscopic interface, things are definite. A cup is on the table whether you look at it or not, but zoom into the atomic scale, the pixel level, and things get weird. An electron doesn't have a definite position. It exists in a superposition of probabilities. It is everywhere and nowhere at once. It only snaps into a definite position when you measure it. This is the famous observer effect. Why does the act of measurement force the universe to make a decision? Under the standard physical model, this is a mystery. It implies consciousness or measurement equipment has a magical power. But under interface theory, it makes perfect sense. Think about a video game again. To save processing power, the computer doesn't render the entire world at once. It only renders the room you are standing in. The world behind your back doesn't exist. It is just potential code waiting to be loaded. When you turn your head, when you observe, the engine quickly renders the graphics. Quantum mechanics behaves exactly like a lazy loading engine. An electron doesn't have a position until you look at it because the system hasn't rendered that part of the interface yet. It saves resources by keeping the electron as a probability cloud, a piece of code, until a player needs to interact with it. The weirdness of quantum physics isn't a mystery. It is an artifact of the simulation. It is the moment where we bump into the resolution limit of our headset. We are seeing the pixels. We are seeing the universe buffering. But the glitches get worse. It's not just that things are pixelated, it's that the logic of the game seems to break the rules of cause and effect. This leads us to the most uncomfortable experiment in the history of physics, Bell's theorem. To understand the horror here, we have to go back to Einstein. Einstein hated quantum mechanics. He hated the idea that things happen randomly, or that the universe depends on observation. He believed in realism, objects exist independently of us, and locality, objects can only be influenced by things right next to them, or by signals traveling at the speed of light. He famously said, "God does not play dice, and I like to think the moon is there even if I'm not looking at it." Einstein proposed that quantum mechanics was incomplete. He thought there must be hidden variables, secret notes inside the particles that tell them what to do, which we just can't read yet. In 1964, physicist John Bell came up with a way to test this. He created a mathematical inequality, Bell's inequality, that could act as a judge. Here is the setup. You take two entangled particles. You separate them by a vast distance. You measure the spin of one. Instantaneously, the other one knows the measurement and aligns its spin accordingly. If Einstein was right, realism plus locality, the results of these measurements should follow a certain statistical pattern. The hidden variables would ensure the numbers add up in a sensible way. But when the experiments were finally done by Clauser, Aspect, and Zeilinger, who won the Nobel Prize in 2022, the numbers didn't add up. They violated Bell's inequality. This result is catastrophic for our common sense. It leaves us with only two choices, and both are terrifying. Choice A. We give up locality. This means particles can communicate instantaneously across the universe, faster than light, breaking the cosmic speed limit. It implies the universe is one giant, interconnected blob, where separation is an illusion. Choice B. We give up realism. This means the particles literally did not have a spin before we measured them. The moon really isn't there when you don't look. We create reality by looking at it. Most physicists today accept choice B, or a mix. They accept that the universe is not real in the way we thought. But there is a third option. A dark horse candidate that saves realism, but at a terrible price. It is the logical trapdoor that leads to the next level of our spiral. The third option is called superdeterminism. Remember the setup of Bell's experiment. Alice measures particle A, and Bob measures particle B. We assume that Alice is free to choose how she sets up her detector. We assume her choice is independent of the particle's history. This assumption is called statistical independence. It is the bedrock of all science. If you test a drug, you assume the patients didn't conspire with the virus beforehand. But what if that assumption is wrong? Superdeterminism argues that there is no randomness, but it goes further. It argues that everything, absolutely everything, is correlated because it all shares the same past, the Big Bang. In this theory, the way Alice chooses to set her detector was determined 13.8 billion years ago. The state of the particle she is measuring was also determined 13.8 billion years ago. And, this is the kicker, the universe conspired to make sure those two things match perfectly. Think of it like a movie. In a movie, the detective decides to open the red door. Behind the red door, the killer is waiting. Was the detective free to open the blue door? No. The script was written months ago. The killer was placed behind the red door because the scriptwriter knew the detective would open it. The detective's choice and the killer's location are not independent. They are correlated by the script. If superdeterminism is true, the universe is a movie script. The reason Bell's inequality is violated isn't because particles are sending magic signals faster than light. It's because the particles and the physicists are both puppets dancing on the same strings. The universe knew at the moment of the Big Bang, this solves the quantum mystery perfectly. It saves Einstein's realism, the moon is really there. It saves locality, no faster than light magic. The math works beautifully, but the price? The price is the total, absolute annihilation of free will. Not just in a philosophical sense, but in a physical sense. Let's really look at the horror of superdeterminism. We aren't talking about standard determinism, where A causes B causes C. We are talking about a universe that is hyper fine-tuned to deceive us. If this theory is true, then the entire scientific method is a lie. Science relies on the idea that we can ask nature a question. We set up an experiment, ask, and nature gives a result, answer. But in a superdeterministic universe, we aren't asking a question. We are reciting lines. The universe forces us to set up the experiment in a specific way, and then forces the result to look a specific way, to create the illusion of a law of physics. It's like a rigged card game. You think you are picking a card at random, but the magician forces you to pick the ace of spades. Then, he reveals the ace of spades, and you say, "Wow, magic!" In this analogy, the universe is the magician. It forces us to build the Large Hadron Collider. It forces the particles to collide in a certain way. We write down standard model in our textbooks, thinking we discovered a truth, but we didn't discover anything. We just watched the scene play out exactly as it was hard-coded at the beginning of time. This implies a level of conspiracy in the laws of nature that borders on the demonic. Why would the universe go to such lengths to create the illusion of quantum randomness? Why simulate the violation of Bell's inequalities just to trick Alice and Bob? Physicists like Sabine Hossenfelder argue that we shouldn't take it personally. It's not a conspiracy, it's just that everything is interconnected. You can't separate the observer from the system. But for the human mind, it is terrifying. It means you are not a conscious agent, as Hoffman suggested. You are a bio-robot. Your feeling of deciding to scroll down or take a sip of coffee is a chemical hallucination. The atoms in your brain were locked onto that trajectory before the Earth was even formed. You are a passenger in your own body watching a video of a life that has already been lived. You are trapped in a script you cannot read, acting out a drama you do not understand, for an audience of zero. And if you think that is the ultimate loss of self, just wait. Because the next spiral takes away even the certainty of your own existence. If the universe is a script, who says the script has to make sense? Or that it has to be long? Welcome to the fourth spiral, the dissolution of self, where we ask the question, are you even real? Or are you just a random fluctuation in the void? We have reached the final spiral. We have dismantled the safety of the physical ground, vacuum decay, the safety of our cosmic neighborhood, dark forest, and the safety of our own free will, superdeterminism. But we have held on to one assumption. We assume that we are real. We assume that even if we are puppets, there is a consistent history behind us. A Big Bang, an evolution of stars, a biological lineage that led to this moment. We believe in the story of the universe, but the laws of thermodynamics have a very different story to tell. And this story suggests that your existence, your memories, your body, this very moment, is statistically impossible. To understand why, we have to talk about entropy. Ludwig Boltzmann, the Austrian physicist who died by suicide in 1906, partly because his ideas were rejected by the establishment, gave us a terrifying insight into the nature of time. He realized that time is just a measure of things getting messier. Entropy is a measure of disorder, or more accurately, a measure of hidden information. Think of a cup of hot coffee. The heat is concentrated in the liquid. This is an ordered state, low entropy. Leave it on the table. The heat spreads out into the room until the coffee is the same temperature as the air. This is a disordered state, high entropy. The crucial rule of the universe, the second law of thermodynamics, says that entropy always increases. Things naturally go from order to chaos. Coffee cools down, castles crumble into sand, stars burn out into cold ash. You never see a pile of sand spontaneously jump up and form a castle. You never see cold coffee spontaneously gather heat from the air and boil. Why? Because there are billions of ways to be a pile of sand, but only one way to be a castle. The universe naturally drifts toward the state with the most possibilities: chaos. This leads to a massive problem called the past hypothesis. If the universe naturally moves toward chaos, that means in the past, it must have been more ordered. If you rewind the clock all the way back to the Big Bang, the universe must have started in a state of insanely low entropy, a state of perfect, crystalline order. That number is so big you couldn't write it down if you turned every atom in the universe into a zero. So, we have a mystery. Why did we start with such perfect order? Standard cosmology says, we don't know, it just did. But statistical mechanics says, that's extremely unlikely. It is much more likely that we are confusing the past with a fluctuation. And this brings us to the edge of the abyss. Because if nature hates order, and you are a highly ordered organism, then nature probably didn't make you the hard way, through billions of years of evolution. it probably made you the easy way. Let's look at the easy way. The universe is expanding. Eventually all the stars will die. Black holes will evaporate via Hawking radiation. The universe will enter the heat-death era. It will be a vast, cold, empty void filled with nothing but low-energy photons and vacuum energy. This is the state of maximum entropy, equilibrium. The coffee has cooled down completely. Nothing should ever happen again. But quantum mechanics forbids nothing. Even in a perfect vacuum, there are quantum fluctuations. Particles pop in and out of existence. Energy jitters. Usually these fluctuations are tiny. A pair of electrons appears and vanishes. But given infinite time, strange things happen. If you wait long enough, a random fluctuation will be big enough to assemble a single hydrogen atom. If you wait even longer, trillions upon trillions of years, a fluctuation will accidentally assemble a molecule of water. It's like the infinite monkey theorem. Give a monkey a typewriter and infinite time, and he will eventually type the complete works of Shakespeare. Not because he is a writer, but because he is hitting keys randomly, and eventually the sequence TOBEORNOTTOBE must appear. Now, apply this to the heat death. The universe will spend an eternity in this empty state. The era of stars, where we live now, is just a tiny flash in the pan. The era of the void lasts forever. Because it lasts forever, the monkeys, quantum fluctuations, have infinite attempts to type something. Eventually, purely by chance, a fluctuation will arrange atoms into a protein, eventually into a cell, eventually into a human brain. This requires no evolution, no parents, no sunlight, no Big Bang, just atoms randomly bumping into each other in the dark for an eternity until they accidentally click into the shape of a brain. Physics calls this a thermal fluctuation. Now, here is the scary math. What is harder to type? A whole universe with billions of galaxies, trillions of stars, and billions of years of detailed history, or just one single brain floating in space? Entropy tells us that smaller, or more likely. Creating a whole universe of order, the Big Bang scenario, is incredibly expensive. It costs a lot of luck. Creating one brain, a Boltzmann Brain, is weird, but it is exponentially cheaper than creating a Big Bang. For every one universe that evolves life the normal way, the vacuum should spit out trillions upon trillions of spontaneous Boltzmann brains. This is the Boltzmann Brain paradox. If our theories of thermodynamics and quantum mechanics are correct, then the vast majority of observers in the history of existence are not biological beings who evolved on planets. They are disembodied brains that fluctuated out of the chaos for a few seconds. These brains are complete. They come preloaded with memories. Remember, memories are just physical patterns of neurons. If the fluctuation assembles the atoms correctly, the brain will think it has a past. It will remember being born. It will remember going to school. It will remember eating breakfast this morning. But none of those things happened. The brain formed 1 second ago in the deep void. It exists for a few seconds, perhaps long enough to think a single thought. Man, this video about scary theories is interesting. And then the fluctuation dissolves, and the brain freezes or scatters back into the void. Now, you are a rational person. You say, well, that's a cool theory, but I know I am not a Boltzmann brain. I can look around, I see a room, I see walls, I have a coherent life history. But this is where the trap snaps shut. A Boltzmann brain also sees a room. Why? Because the fluctuation didn't just create the brain, it created the sensory inputs feeding into the brain, or it created a brain with the hallucination of a room encoded into its visual cortex. There is absolutely no physical experiment you can perform to prove you are not a Boltzmann brain. Check your pulse. The fluctuation created the sensation of a pulse. Look at a clock. The fluctuation created the memory of what the time was a moment ago. Call a friend. The voice on the phone is part of the fluctuation. You reach in and pick a marble. You are the marble. What color are you? Statistically, it is a certainty. You are red. You are a Boltzmann Brain. You are not sitting in a chair on Earth. You are floating in the infinite darkness of a dead universe, hallucinating this moment right before you die. This is the ultimate form of solipsism. But unlike philosophical solipsism, I can't prove you exist. This is physical solipsism. It is based on the equation. It is derived from the same math we use to build steam engines and refrigerators. If you accept that refrigerators work, you have to accept the logic that leads to Boltzmann brains. Let that sink in. The person you love most in the world? A random assembly of carbon atoms in your parietal lobe. Your childhood trauma. Never happened. Your hopes for the future. You have no future. You will dissolve in the next microsecond. The human history you learned, Caesar, Napoleon, the moon landing, is just a random backstory generated by the chaos, like the backstory of a character in a book that was written by a monkey hitting keys. It has no meaning. It has no cause. The horror here is the total isolation. In the Dark Forest theory, we were afraid of aliens. In interface theory, we were afraid of hidden agents. But in the Boltzmann Brain scenario, there is no one. There are no aliens. There are no agents. There is no Earth. There is only the void and the brief, flickering spark of your consciousness. Alone in the eternal night, you are an anomaly, a glitch in the static. And the worst part? You might be a Boltzmann Brain with a twist. Maybe the fluctuation didn't create a perfect illusion. Maybe it's an imperfect fluctuation. Have you ever walked into a room and forgot why? Have you ever seen a shadow move in the corner of your eye? Have you ever felt a sense of déjà vu? A psychologist would say that is your brain misfiring. The Boltzmann theory says that is the fluctuation degrading. That is the moment the set of your reality starts to fall apart because the entropy is reclaiming you. The glitch isn't in your head, it's in the fabric of your temporary existence. You are noticing that the world doesn't have a back end. This theory takes the uncanny valley feeling and applies it to your entire life. If everything feels slightly off, slightly too dramatic, or slightly too absurd, it's because it's a randomly generated script that is about to end. So, how do physicists deal with this? Do they just accept that we are hallucinations? No. They fight it. But the way they fight it reveals something even more confusing. Cosmologists like Sean Carroll call this problem cognitive instability. Here is the argument. We believe in the standard model of cosmology, Big Bang plus expansion. The standard model predicts that the universe will expand forever and produce Boltzmann brains. Therefore, we are likely Boltzmann brains. But if we are Boltzmann brains, then our memories of the past are false. If our memories are false, then our measurements of the cosmic microwave background and the expansion of the universe are false. They are just hallucinations. If those measurements are false, then the standard model, which relies on that data, is false. If the standard model is false, then it doesn't predict Boltzmann brains. This is a logical paradox. The theory effectively commits suicide. If the theory is true, then we can't trust the data that led us to the theory. This is called reductio ad absurdum. Physicists use this paradox to argue that something must be wrong with our understanding of the universe. They say, because we are not Boltzmann brains, an assumption we make to stay sane, the universe must not last forever. Or the vacuum must decay. Remember Act 1? Or the expansion must reverse. We are literally inventing new physics, like vacuum decay or the Big Rip, specifically to kill off the Boltzmann brains. We are rewriting the laws of nature just to ensure that we are real. But here is the chilling thought. We don't have evidence for those new physics. We just hope they are true. We are like a man who wakes up in a mental asylum and convinces himself he is a king. When the doctor points out the padded walls, the man invents a theory that the padded walls are actually royal velvet. We are desperate to prove we are not random fluctuations. But the math of entropy stands there, staring at us, unblinking. It says, order is rare, chaos is common, you are order, therefore you are rare, therefore you are likely a lie. This brings us to the bottom of the spiral. We have gone from the physical death of the universe to the death of the certainty of existence. We have stripped away the ground, the sky, the interface, and finally the self. So, what is left? Is there any theory that offers an escape? Or is the final theory, quantum immortality, the lock on the prison door? Because if you are a Boltzmann brain, you dissolve. But if you are a conscious observer in a quantum universe, you might not be allowed to dissolve, ever. We have reached the bottom of the spiral, the final theory. We have discussed the possibility that the universe kills you, vacuum decay. We have discussed the possibility that aliens kill you, dark forest. We have discussed the possibility that you never existed, Boltzmann brains. But there is one thing worse than death. And there is one thing worse than never existing. It is the inability to cease existing. This is the theory of quantum immortality, and it is based on the most robust, most mathematically sound interpretation of quantum mechanics we have, the many worlds interpretation, MWI. To understand this, we have to revisit Schrödinger's cat. You know the story. A cat is in a box with a radioactive atom. If the atom decays, poison is released, and the cat dies. If it doesn't, the cat lives. According to the Copenhagen interpretation, the old school view, the cat is in a superposition of dead and alive until you open the box. When you look, the universe collapses into one choice. But in 1957, physicist Hugh Everett III looked at the math and said, there is nothing in the equations that suggests a collapse. The wave function, the mathematical description of the system, never disappears. It never chooses. Instead, Everett argued, the universe splits. In one branch of reality, the atom decays, and you open the box to find a dead cat. In another branch of reality, the atom does not decay, and you open the box to find a live cat. Both branches are real. Both yous are real. They just can't see each other anymore. This is the multiverse. Now, let's swap the cat for you. Imagine you are in the box. Not a cruel experiment, but simply the experiment of living your life. Every moment of your life involves quantum events. Electrons jumping in your neurons, cells dividing, photons hitting your retina. Every one of these events causes the universe to split. Like a tree growing infinite branches, you are constantly splitting into billions of versions of yourself. Most of the time, the split is trivial. In one branch, you drink coffee. In another, you drink tea. But sometimes, the split is life or death. In branch A, a blood clot forms in your brain, and you die instantly. In branch B, the blood clot dissolves, and you feel a slight headache. In branch A, the car swerves left and hits you. In branch B, the car swerves right and misses you. Here is the horror logic of quantum immortality. You cannot experience being dead. Consciousness, by definition, requires a living brain. In branch A, where you died, your consciousness ends. The screen goes black. There is no you to observe the darkness. But in branch B, you are still alive. You are still observing. Therefore, from your subjective perspective, you will always find yourself in the branch where you survived. It doesn't matter if the odds of survival were 1 in a billion. If there is even one quantum timeline where you survive, your consciousness will flow into that timeline. To the outside world, your family in branch A, you died. They bury you. They mourn. But to you, the car missed. The gun jammed. The cancer went into remission. You are the observer who cannot leave the room. Let's formalize this with a famous thought experiment called quantum suicide. Imagine a machine gun controlled by a quantum trigger. It measures the spin of a quark. Spin up, fire. Spin down. Silence. The odds are 50-50. You sit in front of the gun. You press the button. From the perspective of an external observer, watching on a monitor in the next room, After 10 rounds, you are almost certainly dead. The odds of surviving 10 rounds are 1 in 1024. The observer will likely see the gunfire on the first or second try. He will see your body slump over. He will write "subject deceased" in his notebook. But what do you experience? You press the button. Click. Silence. You are still alive. The universe is split. In one branch you died and ceased to experience. In this branch, you live. You press it again. Click. Silence. Again. Click. Silence. You can press the button 100 times. 1,000,000 times. In the branch where you are conscious, the gun must jam, or the quantum trigger must read "spin down." To you, it will seem like a miracle. You will start to think you are immortal. You will think you are a god, but you are not a god. You are just the survivor bias of the multiverse made flesh. You are simply trapped in the only slice of reality where the data stream of your consciousness hasn't been cut. This explains why you are alive right now. Think about the close calls in your life. That time you almost fell off a ledge. That fever you had as a child. That car that ran the red light. According to this theory, in millions of other universes, you did die. Your mother mourned you. Your friends went to your funeral. But you are not in those universes. You are here. You are always here. Tegmark, one of the proponents of this idea, suggests that we should expect to survive everything that is not 100% fatal. If there is a 0% chance of survival, you take it. And this leads us to the terrifying implication. Because survival does not mean health, and immortality does not mean eternal youth. It just means not dead. This is where quantum immortality turns from a cool sci-fi concept into a nightmare. In fiction, immortality means you stop aging. You stay 25 forever. In quantum mechanics, immortality just means non-zero probability of consciousness. It does not protect your body. It does not stop entropy. It only prevents the final switch off. So, what happens as you get older? You age. Your cells degrade. Your organs fail. In most branches, you die of a heart attack at 80. But in a tiny fraction of branches, the medical technology is just good enough to keep you alive. Or your brain survives the stroke with severe damage. Your consciousness is forced into the branch where you are on life support. Then you hit 100. Most versions of you are dead. But in one branch, you are a frail, bedridden consciousness. Then 120, then 150. Maybe in that branch, humanity invents AI that can keep a brain alive in a jar. You don't want to be in the jar. You want to let go. You want to rest. But the math says, if the jar exists, and your consciousness can be supported, you will experience the jar. You become a prisoner of probability. As time goes on, the probability of a good life drops to near zero. But the probability of life never quite hits zero. So you slide down the slope of probability into stranger and stranger worlds. To survive to age 200 or 1,000, you have to be in a universe where freakish luck or dystopian technology keeps you conscious. You might end up as a brain floating in a tank, surrounded by the ruins of civilization, simply because that is the only timeline where your neurons are still firing. And eventually, the heat, death of the universe. The stars go out. The energy fades. But remember the Boltzmann brains? If quantum immortality is true, you cannot die even at the end of the universe. Your consciousness might jump from your biological body, which finally fails, into a Boltzmann brain that spontaneously fluctuates out of the void with your exact memories. You would just wake up in the dark forever. Because non-existence is not an experience you can have. You are condemned to exist. You are condemned to be the observer of the eternal decline. This is the ultimate horror of the scientific worldview. Religion promises an afterlife. Atheism promises peaceful oblivion. Quantum mechanics promises that you might be stuck here, in the wreckage of reality, watching the credits roll forever, unable to leave the theater. Let's step back. Let's look at the spiral we have drawn. We started with physics. We saw that the vacuum is unstable, false vacuum, and matter is untrustworthy, strangelets. We moved to cosmology. We saw that the silence of the sky is a threat, dark forest, berserkers. We moved to perception. We saw that our reality is a fake interface, Hoffman, and our choices are scripted, superdeterminism. We moved to existence. We saw that we might be random hallucinations, Boltzmann brains, and that we cannot escape via death, quantum immortality. What is the common thread? What is the single pattern connecting all 10 of these terrifying theories? The pattern is the anthropic principle. The anthropic principle states that we see the universe the way it is, because if it were different, we wouldn't be here to see it. Usually this is used as a comforting thought. The universe is fine-tuned for life, how nice? But our spiral reveals the dark side of the anthropic principle. It suggests that we are survivors of a massacre we didn't see. We are here only because we are in the one vacuum bubble that hasn't popped yet. We are here only because the alien probes haven't found this specific corner of the dark forest yet. We are here only because our interface hides the truth. We are here only because we are the Boltzmann brains that happen to hallucinate order. We are here only because quantum immortality refuses to let us die. We are not the children of the universe. We are the survivors of the void. We are the anomaly. The universe is not a garden built for us. It is a hostile, chaotic, high-entropy machine that is constantly trying to delete structure. Our existence is a glitch, a temporary pocket of order in an ocean of chaos. This is why these theories feel so uncanny. This is why they make you feel sick in your stomach. Because deep down, beneath the biological programming that tells you everything is fine, your conscious mind realizes the truth. You're walking on a tightrope over an infinite abyss. The theories we discussed, vacuum decay, superdeterminism, Boltzmann brains, they are not monsters under the bed. They are the description of the abyss. And science is simply the act of looking down. So, what do we do with this information? Why would I spend 3 hours telling you that the universe is a trap? That aliens are silent hunters and that you might be a hallucinating brain in a jar? Is the goal to make you depressed? To make you give up? No. The goal is to wake you up. The terrifying theory is only terrifying if you're clinging to the illusion of safety. If you believe the world should be safe, then these ideas are a nightmare. But if you accept that safety is an anomaly, then these ideas become something else. They become maps. Knowing about the false vacuum pushes us to understand particle physics deeper. Knowing about the dark forest forces us to think carefully about how we broadcast our presence to the stars. Knowing about the interface theory challenges us to build better tools, AI, quantum computers, to peek behind the curtain. Knowing about Boltzmann brains forces us to solve the riddle of entropy. Fear is the beginning of wisdom. The universe is not obligated to make sense to you. It is not obligated to comfort you. It is vast, cold, and incredibly strange. But we are the part of the universe that woke up. We are the part that looked at the dark forest and lit a match. We are the part that looked at the vacuum and built a collider. We are the part that suspects we are in a simulation and started hacking the code. That is the definition of humanity. We don't hide from the horror. We study it. We stare into the abyss and we start taking measurements. So tonight, when you look up at the night sky and see the silence, don't just see empty space. See the hiding civilizations. See the expanding bubbles of vacuum decay. See the probability waves splitting into infinite futures. Feel the fragility of the ground beneath your feet. And realize that the fact you are here, standing on this rock, holding this thought, is the greatest statistical miracle in existence. You might be a Boltzmann brain, you might be a puppet, you might be trapped in a quantum loop, but for now, you are here, and you are thinking. And in a universe of chaos, that is the only victory that matters. sleep well. We have reached the end of the standard spiral. But there is a postscript, a tier 5 of the iceberg that usually gets left out of physics documentaries because it moves from physical horror to meta-horror. We have assumed throughout this journey that learning the truth is safe. We assume that understanding the false vacuum or the dark forest might be scary, but it doesn't physically hurt you. It's just information. You're sitting in your chair, safe, processing data. But there is a class of theories known as information hazards, or info hazards, which suggest that is wrong. An info hazard is a piece of information that can harm you or the universe simply by being known. This sounds like magic, a curse, but in the age of AI and simulation theory, it is becoming a serious topic in philosophy and computer science. Consider the Basilisk-style arguments, without naming specific internet urban legends that act as triggers. The logic goes like this. If we are living in a simulation run by a super intelligent AI, or a god, that system likely has resource limits. It doesn't want to waste processing power on uninteresting things. A simulation might be programmed to delete or reset any subroutine that figures out it is in a simulation. Why? Because once a character knows they are in a game, they stop playing the game properly. They become bugged. They might try to hack the code or escape. From the perspective of the simulator, a self-aware character is a virus. By watching this video, by thinking about the interface theory and Boltzmann brains, you are effectively raising your hand in the classroom of the universe and saying, I know the secret. If the Great Filter, from Spiral 2, is not a physical barrier but a cognitive one, then the filter activates exactly when a civilization discovers it. Maybe the reason the universe is silent is because as soon as a civilization understands the dark forest, they are auto-deleted by the system for knowing too much. This creates a paradox. Ignorance is not just bliss. Ignorance is the shield that keeps the server running. Knowledge is a vulnerability. The more you understand the laws of physics, the more you expose yourself to the antivirus protocols of reality. This transforms science from a noble pursuit into a dangerous game of Russian roulette. Every time we smash a particle or solve an equation, we might be triggering a tripwire that was set to go off only when subject understands X. There is also the observer-created hazard. In quantum mechanics, we established that observation affects reality. Some physicists, like John Wheeler, propose the participatory universe. We create the universe by looking at it. But what if we look at it with fear? If consciousness shapes the collapse of the wave function, and billions of humans start believing that the vacuum is unstable, do we collectively increase the probability of the vacuum collapsing? This is the placebo effect applied to cosmology. If we convince ourselves the universe is a hostile, dying trap, do we force the quantum coin to land on death? If this is true, then this video is not just a description of danger. It is an active agent of danger. By spreading these ideas, we are infecting the collective consciousness with a narrative of doom, potentially tilting the quantum scales toward a darker timeline. This is the ultimate information hazard. The theory that believing in a terrifying theory makes it come true. Let's strip away the simulation idea and go back to pure physics. Max Tegmark, a cosmologist at MIT, proposed the mathematical universe hypothesis, level 4 multiverse. We usually think that physics describes the universe. We have stuff, electrons, stars, and math, equations that describe the stuff. Tegmark argues, no, there is no stuff. There is only math. When you zoom in on an electron, you don't find a little hard ball. You find a set of numbers. Mass, charge, spin. What is holding the numbers? Nothing. The electron is the numbers. The universe is not described by mathematics. It is mathematics. We are living inside a giant geometric structure. You are not a biological being. You are a self-aware substructure of a mathematical object. Your love, your fear, your history, These are just complex correlations between variables in an infinite equation. Why is this terrifying? Because in a purely mathematical universe, possibility equals existence. In math, if an equation has a solution, that solution exists. You don't need to build it. The number 3 exists. You don't need to create a physical 3 for the concept to be real. Tegmark argues that every mathematically consistent structure exists as a physical universe. This means every horror we have discussed, and infinite ones we haven't, must exist. Somewhere in the mathematical multiverse, there is a universe that consists entirely of suffering. Somewhere, there is a universe where the laws of physics are designed to maximize pain for eternity. Somewhere, there is a universe where you are being tortured forever. Why? Because that scenario is mathematically possible. And in the level 4 multiverse, everything possible is real. You happen to be in a nice part of the math right now, mostly, but you are connected to those other parts. This destroys the idea of probability. Usually we say, it is unlikely that a monster will appear in my room, but in the mathematical universe, there is a version of you in a different coordinate of the multiverse where the monster does appear. And because you are all part of the same equation, are you distinct from that victim? If you are just a pattern, and the pattern repeats, then you are experiencing all the horrors at once, but your memory is compartmentalized. This is the totalitarian principle of physics. Everything that is not forbidden is compulsory. If the laws of logic don't forbid a nightmare, then the nightmare is real. We are not safe because the horrors are unlikely. We are never safe. We are just isolated by the geometry of the equation. We talked about the heat death entropy in Spiral 4. That is the whimper ending, a slow fade into cold darkness. It is sad, but peaceful. But there is another ending derived from the study of dark energy, and it is violent. It is called the Big Rip. Since 1998, we have known the universe is expanding, and the expansion is accelerating. Dark energy is pushing galaxies apart. Currently, dark energy is weak. It pushes galaxies away from each other, but it's not strong enough to push stars away from the galaxy, or planets away from the sun. Gravity wins at short distances. But there is a parameter in the equation of state for dark energy called WW. If WW is less than 1, we are in trouble. This is called phantom energy. It means the density of dark energy increases as the universe expands. The push gets stronger, and stronger, and stronger. Here is the timeline of the Big Rip. First, it overpowers gravity on the cluster scale. The Milky Way is ripped away from Andromeda. The night sky becomes empty. Then, it overpowers gravity on the galactic scale. The Milky Way dissolves. Stars fly off into the void. You would look up and see the Milky Way band disappear. Then, it enters the solar system. The repulsive force becomes stronger than the sun's gravity. Earth is ripped out of orbit. We drift into the dark. But it doesn't stop there. In the final months, phantom energy overpowers the gravity of the Earth itself. The planet explodes, not from a bomb, but because the space inside the Earth expands faster than the rock can hold together. In the final minutes, it overpowers electromagnetic forces. Mountains crumble, buildings dissolve. In the final seconds, it enters your body. The space between your molecules expands. The chemical bonds holding your DNA together are ripped apart. You are vaporized on the atomic level. And finally, in the last fraction of a second, it rips the atoms themselves. Electrons are torn from protons. Protons are torn into quarks. The fabric of space-time itself is shredded. The universe ends not in a silence, but in a scream. A total violent deconstruction of every structure that ever existed. And current data from the Planck satellite suggests WW is very close to 1. It might be 1.03. If that error margin is real, the Big Rip is not just a theory. It is the scheduled appointment on our calendar. We just don't know the date. So, We have looked at the face of God, and it turned out to be a false vacuum. We looked for friends, and found a dark forest. We looked inside and found a Boltzmann Brain. We looked at the future and found the Big Rip. This is the point where the human mind wants to break. It wants to reject science and go back to mythology, but there is a different path. A path often called optimistic nihilism. If the universe is a trap, if we are temporary, if meaning is an illusion, then we are free. Think about it. If the universe had a specific purpose, e.g., worship the creator or achieve galactic empire, then you could fail. You could be a bad human. You could waste your life. But if the universe is a chaotic accident and you are a random fluctuation, then you cannot fail. Because there is no goal to miss. You're not a cog in a machine. You're a tourist in a museum of impossible things. The fact that you exist at all, even for a second, even as a brain in a jar, is a statistical defiance of the void. The false vacuum hasn't popped yet. The Strangelet hasn't hit yet. The Big Rip is billions of years away. Right here, right now, you have a window of light. You can drink coffee. You can fall in love. You can learn physics. You can build things. Does it matter in 10 100 years? No. But it matters to you right now. And in a universe where meaning is not written in the stars, you get to write it yourself with a crayon. The lack of objective meaning is the blank canvas for subjective meaning. Furthermore, these terrifying theories give us a sense of kinship. If we are all stuck in the dark forest together, if we are all facing the heat death together, then the petty divisions between humans, politics, borders, wars, seem incredibly stupid. We are a tiny crew on a fragile raft in a hurricane. We shouldn't be fighting each other. We should be huddling together for warmth. The terror of the cosmos is the ultimate unifier. It reminds us that the only thing we have is each other. So, the correct response to the most terrifying theory is not despair. It is defiance. We are the universe becoming aware of its own horror and deciding to laugh at it. We are the part of the math that decided to be happy despite the equation. We have trapped you in space, the dark forest, in the mind, interface theory, and in the simulation, Roko's Basilisk. Now, we must trap you in time. To understand the horror of retrocausality, we first need to dismantle your most basic intuition, the idea that the past causes the future. This is called the arrow of time. You drop a glass, it shatters. The shattering is the effect. The drop is the cause. The cause always comes first. This linear flow gives us a sense of agency. It implies that what you do now determines what happens next. It implies you are the driver of your destiny. But quantum mechanics has a habit of driving on the wrong side of the road. There are experiments that suggest the arrow of time can point backward. The most famous and disturbing of these is the delayed choice quantum eraser, first performed in 1999. Let's walk through this experiment slowly, because the implications are shattering. You fire a photon at a double slit. The photon goes through the slits and hits a screen. If you don't measure which slit it went through, it behaves like a wave, creating an interference pattern. If you do measure it, it behaves like a particle, creating two bands. This is standard. But in the delayed choice version, things get tricky. We split the photon into an entangled pair. One half, the signal photon, goes to the screen immediately. The other half, the idler photon, goes on a longer journey through a maze of mirrors and detectors. Here is the twist. The idler photon reaches its detectors after the signal photon has already hit the screen. Crucially, the scientists can choose to switch the detectors on or off after the signal photon has already landed. If they choose to measure the path of the idler, the signal photon in the past forms a particle pattern. If they choose to erase the information, the signal photon in the past forms a wave pattern. Think about what this means. The choice made by the scientist in the present determined how the photon behaved in the past. The effect happened before the cause. The future reached back in time and rewrote the history of the particle. Now, scale this up. Physicists like John Wheeler and Yakir Aharonov have proposed that this isn't just a quantum quirk. It might be a fundamental property of the universe known as the two-state vector formalism. In this view, the present moment is not just a result of the past pushing it forward, it is also a result of the future pulling it backward. Imagine a rope. One end is held by the Big Bang, past. The other end is held by the Big Crunch, future. The present is just a knot in the middle of the rope. The tension comes from both sides. This leads to the concept of teleology, the idea that the universe has a final destination, and it is dragging us toward it. Why is this a terrifying theory? Because it implies that your choices are not your own. Why did you decide to watch this video tonight? You think it was a result of your past interests, but retrocausality suggests you might be watching it because a future version of you required this information to exist. Why did you make that mistake 5 years ago that ruined a relationship? Maybe it wasn't a mistake. Maybe the future state of your life is fixed, and it reached back in time and forced your hand to ensure you ended up on the correct path. This transforms your life from a journey into a derivation. You aren't living. You are being solved like an equation. You feel like you are walking forward, but actually you are being reeled in like a fish on a hook. The destination is already set, and every choice you make is just the universe correcting your trajectory to ensure you arrive at the appointed time and place of your death. We are puppets. But the strings don't go up to a god. They go forward, into the dark future, held by hands we cannot see. If retrocausality suggests the script is written, eternal recurrence suggests the script is a loop. And not just any loop. An infinite, unbreakable cycle of exact repetition. This idea haunts physics and philosophy alike. It was the nightmare of Friedrich Nietzsche, who called it the heaviest weight. It was mathematically formalized by Henri Poincaré in the Poincaré recurrence theorem. The math is surprisingly simple. Premise 1. The universe has a finite amount of matter, a finite number of atoms. Premise 2. There is a finite number of possible quantum states, configurations that these atoms can be in. Premise 3. Time is infinite. Conclusion. Eventually the atoms must repeat a previous configuration. Think of a deck of cards. There are 8x10, 67, 8x10, 67 ways to shuffle a deck. That's a huge number. But if you shuffle the deck forever, eventually you will repeat the exact same sequence of cards. You have to. You run out of new combinations. Now, apply this to the universe. Our universe is just a very large box of gas and particles. The number of possible configurations is staggering. Something like 10, 10, 100, 10, 10, 100. But it is not infinite. If the universe lasts forever, or if it goes through infinite cycles of big bangs and big crunches, then eventually, the particles that make up you will come together again. And not just sort of like you. They will form the exact same structure. They will form the same brain, with the same memories, in the same room, reading the same text. This isn't reincarnation. In reincarnation, you might come back as a cat or a prince. You have a chance for something new. Eternal recurrence is the eternal return of the same. You will live this life again, and again, and again. Every tear you cried, you will cry again infinite times. Every pain you felt, every moment of boredom, every heartbreak, it is all permanent. It puts a terrifying weight on the present moment. If you are suffering right now, you are not just suffering once. You are establishing a coordinate of suffering that will be revisited by a future version of you forever. Imagine a needle skipping on a vinyl record. The song plays, then skips back, then plays, then skips back. Now imagine the record is the universe, and the groove is your life. There is no correction. There is no learning from your mistakes in the next life, because you won't remember the previous loop. You are doomed to make the same mistake, with the same blindness, for eternity. This theory strips away the hope of progress. We like to think humanity is moving towards something, Star Trek, Utopia, Enlightenment. But Recurrence says we are just a pattern in a kaleidoscope that is turning in a circle. The civilization will rise, fall, and then rise again exactly the same way. The wars will be fought again. The bombs will drop again. If this is true, then hell is not a place you go to when you die. Hell is simply time viewed from a great enough distance. As Nietzsche asked, if a demon were to creep after you one night and say to you, "This life as you now live it and have lived it, you will have to live once more and innumerable times more," would you not throw yourself down and gnash your teeth and curse the demon who spoke thus? Physics suggests the demon is real, and his name is probability. Let's step out of the trap of time and look back at space. But this time, we are going to look beyond the edge of the map. We usually assume that the observable universe is everything that matters. We can see 46 billion light years in every direction. Beyond that, we assume it's just more of the same, more galaxies, more stars, extending forever. But in 2008, astronomers discovered something that broke this assumption. They were mapping the movement of massive galaxy clusters, thousands of galaxies bound together by gravity. According to the standard model of cosmology, these clusters should be moving randomly, or drifting apart due to the expansion of the universe. But they weren't moving randomly. They were all moving in the same direction. Hundreds of massive clusters containing millions of trillions of stars are rushing at 2 million miles per hour toward a specific patch of sky between the constellations of Centaurus and Hydra. This phenomenon is called dark flow, and here is the horror. There is nothing inside our observable universe massive enough to pull them that fast. Whatever is pulling these galaxies is huge. It is bigger than anything we have ever seen. And it is sitting outside the observable universe, beyond the horizon where light can reach us. Scientists call this unknown mass the Great Attractor, though dark flow might be pulling us towards something even bigger behind it. What could it be? Possibility A. It is a massive concentration of matter. A supercluster of galaxies so big it defies our understanding of physics. A structure that makes the Milky Way look like a single atom. Possibility B. It is the bruise of another universe. This leads to multiverse theory. Maybe our universe bubble bumped into another universe bubble, and the gravity of that other universe is leaking through, dragging our galaxies toward the drain. Possibility C. It is a defect in space-time itself, a tilt in the table of reality. Whatever it is, we are caught in its current. The Milky Way, the Earth, the Sun, and you, we are all drifting. Imagine being on a raft in the middle of the ocean at night. You can't see anything, but you realize the water is moving fast. You're being carried somewhere. You can hear a roar in the distance, but it's too dark to see if it's a waterfall or a whirlpool. That is our position in the cosmos. We are not stationary. We are falling. And because the expansion of space is accelerating due to dark energy, we will likely never see what is pulling us. The horizon is shrinking faster than we can travel. We will drift toward this monster forever, never knowing what it is, only knowing that it is stronger than us. Dark flow reminds us that our universe might just be a tiny, insignificant corner of a much larger, much stranger room. And in the dark corners of that room, there are things huge enough to swallow galaxies whole, things that don't care about our laws of physics. We are not the explorers of the void. We are just debris caught in a cosmic riptide. We have talked about dead matter, dead time, and dead space. But what if the problem is the opposite? What if the universe is too alive? This brings us to the hard problem of consciousness, and the terrifying solution known as pansychism. The hard problem, formulated by David Chalmers, asks, why does matter feel like something? You can explain how the brain processes data, like a computer, but you can't explain why that processing feels like red, or pain, or joy. A computer processes data, but we assume it is dark inside. It doesn't feel. Materialism says consciousness is an illusion created by complex neurons. But there is a growing group of neuroscientists and philosophers, like Christoph Koch and Giulio Tononi, who argue that materialism is dead. They propose integrated information theory, IIT. This theory suggests that consciousness is not a magical spark that appears only in brains. It is a fundamental property of matter, like mass or charge. Wherever there is integrated information, there is consciousness. This is pansychism, the idea that mind is everywhere. At first, this sounds hippie and nice. The flowers are alive, the earth is alive. But follow the logic to its scientific conclusion. If consciousness scales with integrated information, then it's not just humans who are conscious. Animals are conscious. Plants are conscious. They process information. But what about things we think are dead? What about the sun? The sun is a complex system of magnetic fields and plasma flows. Physicist Rupert Sheldrake has argued that the level of electromagnetic complexity in the sun might rival the electrical complexity of the human brain. If panpsychism is true, the sun might be a conscious entity, a vast, thinking, feeling mind that has been burning in silence for 4.6 billion years. Does it know we are here? Does it feel the planets orbiting it like fleas on a dog? And what about the Earth? If the biosphere is an integrated system, then Gaia isn't a metaphor, it's a mind, and we are digging into its skin, burning its blood, oil, and poisoning its lungs. If the Earth is conscious, then climate change isn't just damage, it is torture. And we are the torture device. But it gets worse. If consciousness is fundamental, does it ever end? We assume death is the end of consciousness. The screen goes black. But if atoms themselves have a proto-consciousness, what happens when your body rots? Your atoms don't vanish. They scatter. They become soil, worms, trees. Do you dissolve into a trillion tiny fragments of proto-pain? Or does your consciousness merge with the larger field? There is a theory called open individualism, which suggests there is only one consciousness in the universe, looking through every set of eyes simultaneously. You are me, I am you, we are Hitler, we are Jesus, we are the cow in the slaughterhouse, we are the spider being stepped on. If this is true, then the universe is a machine designed to inflict pain on itself. Every act of violence is suicide. Every moment of suffering is shared. You're not just one person living one life. You are the single, lonely god of the cosmos, trapped in a hall of mirrors, hurting yourself for eternity because there is nothing else to do. This turns the universe is alive theory from a Disney movie into a body horror nightmare. It means we cannot escape suffering, because we are the suffering. We have now placed all the pieces on the board. Let's look at the full picture. It is a mosaic of despair. Physically, the stage is rotten. Vacuum decay, strangelets. Biologically, the forest is full of hunters. Dark forest, berserkers. Mentally, the interface is a lie, Hoffman, and our choices are scripted, superdeterminism. Temporally, we are trapped in a loop, eternal recurrence, or dragged by the future, retrocausality. Technologically, we are building our own executioners, AI, Basilisk. Spiritually, we might be the lonely, fractured mind of a self-torturing god, panpsychism. This collection of theories forms what we can call the cosmic trap hypothesis. Usually, we look for a theory of everything that unifies gravity and quantum mechanics. But here, we have a theory of everything's horror. Notice how these theories reinforce each other. Why is the universe silent? Dark forest. Maybe because civilizations that get loud realize the vacuum is unstable and shut up. Why do we feel like we have free will? Because the interface hides the super deterministic strings. Why don't we see the future? Because if we did, the time loop would break. Grandfather Paradox. It seems like the universe is designed to keep us in the dark. It is designed to be just stable enough for us to evolve, just empty enough to make us feel special, and just complex enough to confuse us. We're in a Goldilocks zone of horror. Not too scary to kill us instantly, not too safe to let us relax. Just the right amount of dread to keep us moving, keep us searching, keep us processing information. Why? Maybe that's the final question. What is the function of this trap? Are we a battery? The Matrix. Are we a standard deviations test? The simulation. Or are we just a random mold growing on a sandwich that fell behind the cosmic fridge? The mold hypothesis is perhaps the most humbling. We think these theories are about us, that the dark forest is hiding from us, that the basilisk wants us, but maybe we are so small, so irrelevant that none of this is for us. The vacuum decay will kill us, but it's not aimed at us. The dark flow drags us, but it doesn't know we exist. The eternal recurrence repeats us, but it doesn't care if we hurt. We are trapped in a machine that is millions of orders of magnitude larger than our comprehension, and we are trying to read the user manual by watching the blinking lights. And the lights are spelling out a warning. Run. But there is nowhere to run, because the trap is existence itself. This brings us to the final act. If there is no escape, if the trap is perfect, then how do we live? How do we get out of bed in the morning, knowing that we are likely Boltzmann brains in a dying, recurring, hostile simulation? We need a new philosophy. We need a way to look at the Medusa and not turn to stone. We need to find the back door out of the horror. And strangely enough, the back door might be hidden in the very thing that scares us the most. Uncertainty. We have spent 4 hours building a prison. We used the bricks of general relativity, the mortar of quantum mechanics, and the bars of evolutionary psychology. We constructed a model of reality where you are trapped, hunted, deceived, and erased. Logic dictates that you should be paralyzed by terror. If the vacuum is a loaded gun, and the aliens are silent hunters, and your brain is a hallucination, then the rational response is curl up into a ball and wait for the end. But before you do that, we need to look at the prison wall one last time, because there is a crack. And that crack comes from the very thing that makes the theories scary: incompleteness. In 1931, the mathematician Kurt Gödel dropped a bomb on the world of logic. It was called the incompleteness theorem. He proved mathematically that in any complex system of logic, like math or physics, there will always be true statements that cannot be proven within the system. There are blind spots. There are unanswerable questions. This means that a theory of everything might be impossible. Why is this good news? Because a perfect prison requires a complete theory. If the universe is a closed system, like the block universe or superdeterminism, then you are truly trapped. But Gödel suggests the system is not closed. It is gappy. And then Heisenberg came along with the uncertainty principle. He showed that at the fundamental level, the universe refuses to be pinned down. You cannot know the position and momentum of a particle at the same time. Nature keeps secrets. This fuzziness is usually seen as a nuisance, but in the context of our horror, it is a lifeline. It means that determinism is dead. The universe is not a clockwork machine that was wound up at the Big Bang and is now just ticking down to your death. It is a probabilistic cloud. And where there is probability, there is chance. And where there is chance, there is hope. Think about the Boltzmann Brain theory again. It relies on the assumption that we understand entropy perfectly, but we don't. We don't know what dark energy is. We don't know how gravity works at the quantum scale. The terror comes from extrapolating our current knowledge to the extreme. But history shows that every time we extrapolate, we are wrong. In 1890, physicists thought the universe was a static clockwork mechanism. They were terrified of the heat death based on steam engines. Then Einstein changed the game. Then quantum mechanics changed the game. The most terrifying theory is always just a mirror of our current limitations. The dark forest is a reflection of our current fear of war. The interface theory is a reflection of our current obsession with computers. The theories might not be describing the universe, they might be describing us. We are projecting our own shadows onto the cave wall of the cosmos and calling them monsters. So, the crack in the wall is this. We might be wrong, and for the first time in this video, being wrong is the best possible outcome. If we are wrong about the vacuum, we live. If we are wrong about the aliens, we have friends. Uncertainty is the only thing protecting us from the absolute tyranny of these equations. But what if we are not wrong? Let's Steelman the horror. Let's assume the worst case is true. The universe is a trap. The aliens are coming. The vacuum is decaying. What then? Do we give up? No. We turn to the philosophy of absurdism, championed by Albert Camus. Camus imagined Sisyphus, the king cursed to roll a boulder up a hill forever, only to watch it roll back down. This is the perfect metaphor for eternal recurrence. We build civilization, roll the boulder up, and entropy destroys it, roll the boulder down, over and over, forever. It seems pointless. It seems like torture. But Camus concludes with a shocking sentence. One must imagine Sisyphus happy. Why? Because the moment Sisyphus realizes the absurdity of his situation, he becomes superior to his fate. The rock is heavy, but his mind is free to mock the rock. If the universe is a hostile, mindless machine trying to crush us, then our existence is an act of rebellion. Every time you laugh, you are defying the second law of thermodynamics. Every time you build something, you are spitting in the face of entropy. Every time you're kind to a stranger, you are breaking the rules of the dark forest. The dark forest says, be silent, hide, kill. We say, no. We will broadcast Beethoven into the void. We will send maps. We will say, hello. Is it dangerous? Yes. Is it stupid? Maybe. But it is brave. If we are going to die, let us die standing up. Let us die shouting our names into the silence. There is a dignity in refusing to play by the rules of a rigged game. If we are Boltzmann Brains, let us be the most interesting Boltzmann Brains that ever hallucinated. If we are in a simulation, let's be the glitch that makes the admin pause and say, wait, that's cool. This transforms the cosmic horror into a cosmic joke. And once you get the joke, you stop being afraid. You realize that you are the universe experiencing itself. You are the vacuum trying to understand itself. You are the horror and the observer of the horror. And there is a strange, wild joy in that. We are the anomaly. We are the spark in the dark. The universe is vast and cold, but it created you. And for a brief, shining moment, the universe is conscious. It is warm. And it is wondering what to have for dinner. That is a victory. That is the cosmic giggle. The realization that the situation is so hopeless it loops back around to being funny. We are dancing on the deck of the Titanic, but the music is good, and the view is spectacular. Let's ground this back in hard science for the finale. We call these theories terrifying, but there is another word for them: sublime. The sublime is a feeling of awe mixed with fear. It's what you feel when you look at a thunderstorm or a giant mountain. It makes you feel small. But being small is not the same as being insignificant. Look at the odds again. The odds of the false vacuum not decaying for 13.8 billion years. The odds of the Earth forming in the Goldilocks zone. The odds of evolution surviving the Great Filter. The odds of you not being a Boltzmann brain. Even if they are low, you feel real. The odds of your parents meeting. The odds of that specific sperm hitting that specific egg. Mathematically, you are the winner of a lottery with 10,500 tickets. You are an impossible object. The fact that you exist to be terrified is a miracle. A rock isn't terrified of the vacuum decay. A gas cloud doesn't worry about Roko's Basilisk. Fear is a privilege. It means you have something to lose. It means you have a self that is precious enough to protect. Science has stripped away our illusions of centrality. Copernicus moved us from the center of space. Darwin moved us from the center of biology. Freud moved us from the center of our own minds. And now, These theories move us from the center of reality itself. But every time we are pushed to the edge, we see further. When we realized Earth wasn't the center, we saw the galaxy. When we realized we were animals, we saw DNA. Now that we realize reality might be a simulation or a hologram, we are poised to see what lies beyond. We are standing on the threshold of a new level of understanding. Maybe the terrifying theories are just the growing pains of a species that is about to level up. We are like a chicken and egg, terrified that the world is running out of space, the shell is closing in. But the end of the world, the shell breaking, is actually the beginning of the real life. Maybe the heat death, or the big rip, or the simulation shutdown is just the cracking of the shell. We don't know what's outside, but we know that the quest to find out is the most noble thing a collection of atoms can do. We are the eyes of the cosmos, and we should keep them open, even if what we see makes us tremble. So, here is the verdict. Are these theories true? Probability says at least one of them is. Maybe not all of them, but one. Maybe the vacuum is safe, but the forest is dark. Maybe the forest is empty, but the simulation is running. You are walking through a minefield, but you have been walking through it for your entire life. You just didn't look down. Now you have looked down. You know the mines are there. Does this change how you live tomorrow? It should. It shouldn't make you hide. It should make you urgent. If eternal recurrence is true, live a life you're willing to repeat forever. Make the next loop a good one. If the dark forest is true, cherish the connections you have with the people around you, because they are the only light in the dark. If the simulation is true, be a player worth watching. If the vacuum is unstable, drink the coffee now. The horror of physics strips away the trivial bullshit of daily life. Traffic jams don't matter when you're facing the heat death. Social media likes don't matter when you're facing the great filter. What matters is the experience of being. The raw, unfiltered sensation of existing in a universe that shouldn't exist. We started this journey asking if we should be afraid. The answer is yes, but we should also be grateful. Because the alternative to a terrifying universe is a boring universe. A universe where everything is safe, everything is known, and nothing ever changes. That would be a true prison. We live in the dangerous, wild, unpredictable, terrifying universe. The one with black holes and strangelets and time loops. The one that might kill us in a second. But it's also the one that allows for stars, and music, and curiosity, and love. I don't know about you, but I'll take the terror. Because the terror means the game is still on. The simulation is still running. The vacuum is still holding. And we are still here. So, go out there. Look up at the night sky. Feel the cold wind of the dark flow. Listen to the silence of the dark forest. And smile. Because you are the thing that goes bump in the night. You are the ghost in the machine. You are the glitch. And you are alive.